Let us move with the topic dataset augmentation and semi-supervised learning. So here is the place where the dataset augmentation belongs. Module 3, the second topic. So if you complete till here, this covers half of the topic, and then challenges in your like what condition local apply. This is very complicated thing. If I'm sure if you study this much is more than enough. Okay, so we'll move to the topic. I'll tell you what is data augmentation. So now we know that machine learning is all about training the model. So if you want to train a model, you have to train with the data. So the more the data is, the better the training is, right? So if you want better training, so you cannot easily collect all this new data every time. Like if you want complex data, is very much expensive, time consuming, and too much hectic. But what actually in data augmentation is that if you have a picture suppose of a cat, now what I can do with this same picture, I can use it as multiple data. How? So for example, if I have a cat, I can change the angle of the photo. So at every degree if I change, I'll have 360 data sample of the data. Then pixel shift, if it is a digital image, I can shift the pixels. So suppose the cat was in center position, if by changing it into 50 pixel, now it is at the right side of the image. I can change and make it as a corner of the image, full left corner of the image, this corner of this. So I can make it move in the every part of the image. So this is one type of thing. And then I can create copies of like that. And this is type of synthetic data which I can create from one single data and train the model in such a way that it's very useful and it's actually trained now, and I can easily identify whether it is a cat or not. So see here what you data set augmentation. It means creating fake or new training data from existing data by applying valid transformations so the model generalizes better. Key line exam. Best way to generalize better is to train on more data. Augmentation creates synthetic data when real data is limited, like I explained you. So real analogies, think of practice of VTU. Solve the same concept using different question formats. You didn't get new syllabus, but you get more practice variety, better exam performance. So this is just a practical examination. Why it works especially for classification. In classification, in the sense like dividing based on types and features. So you are dividing the actual input based on features. So we map a high dimensional input X, image, audio, text to a single label Y. In essence, for example, sports related image, sports related audio and text will be labeled to sports label. So we will be you know mapped to sports level. So that's what this is. The biggest challenge is making the model invariant to many transformations. So we can generate new X, Y easily by transforming X while keeping Y same. So in the sense what, without changing the label, that is sports label, I want everything to be sports, but I just have to change the image, audio or text, but I have to change in such a way that it will belong to sports category itself. Like that is the meaning over here. Common augmentation example. If you read it again, you'll understand what I explained. So see here, translation, shift few figures. So I told you, right, by shifting the digital image pixels left, right, I can make it like look in the corner or middle. Anyway, I can change the position of it. Rotation, I can change the angle of it, changing to angle. Scaling, zooming out. These often improve generalization even if CNN already has some translation invariance via convolution pooling. See, they might ask you common augmentation example or methods to do dataset augmentation. Here I have just written 3 points, but these 3 points can actually be explained for one whole page or two whole pages. I told you, right, translating few shifts. You can talk about right shift, left shift, up and down shift, and rotating in certain angles, 90 degree, 180 degree upside, making it look upside down, and then along with translation, you can do rotation as well. So suppose I'll tell you. See, yeah, very simple. So this is the image. Suppose our animal is here. Okay, let me just make it like this, whatever it is. So now rotation, what will do while I'm rotating it, see, suppose I rotate some angle, it become like this, then it becomes like this, then I can easily do like this. See, this is different angles, but at different angles. So what is translation? I can put here, I can make it place here anyway. So if I place here, then I'll rotate it. Okay, so translation, rotation, this is one thing. Okay, understood. Then scaling won't be much mixed with other two, because scaling is just zooming and zooming out. So basically wherever you do, but yeah, you can do rotation and scaling, like zoomed picture of rotated images, or zoomed out image, like that. So you can easily use this type of example and then explain completely, so you don't have to worry about that. So see, these often improve generalization even if CNN, the convolution neural network, already has some translation invariance via convolution convolution or pooling. So we'll see what is pooling in the upcoming modules and all. Important question, very scoring point. So important questions. So what you have to remember during data set augmentation, this is a must explain. So sometimes what happen, like I said, see this is shifting. So what happens now? I have B. So see, sometimes what happen if I if I make it like shift, what is that? Invert the image, mirror image type of things. So what will happen? It will become D. So what is happening? It is changing the meaning, actual meaning. So it is changing the class itself. Okay, so this shouldn't happen. If 6 is there, if I tilt it towards 9, see it tilt it to 180 degree, it becomes 9. So it is changing the class. So that should not occur. Okay, so transformation that's in correct class level. So example, see, so horizontal flip or A180. So this happens in rotation itself. Okay, flipping and rotating happens in that. So can change the class, not allowed. So noise injection is equals to augmentation. Adding small random noise to inputs is also a form of data set augmentation. In the sense, suppose you have a clear audio, but you're trying to add some construction sound in the background, so that the AI can you can train the model in such a way that it can specifically concentrate on the actual voice rather than background noise. So you can understand the voice. So there is a background noise. So he is talking to speak. That is a background noise. So I don't have to focus on the background noise. I can focus on the actual voice. See. Oh, see, improves robustness because neural nets can be sensitive to noise used in denoising autoencoders. So how this noise cancellation works in our earbud, it's based on that itself. So they first read the outside noise and then they send the counter waves. For example, if this is the noise coming in pattern, so he will send exact wavelength which will hit each other and cancel out the noise. So that's why you cannot hear anything. Noise can be applied to inputs or hidden units, augmentation at multiple abstraction levels. Dropout can be seen as creating new inputs by multiplying with noise. Later topic. So exam note, control experiments. When comparing algorithm, ensure both use the same augmentation scheme. Otherwise, improvements may come from augmentation, not the algorithm. It's just one thing for them to understand. So now we'll move to semi-supervised. Oh, okay. So we'll move. It's just very small thing, but we'll see in the next video because I don't want you guys to look at the length of the topic and think, oh my god, yeah, that was too much. So I want to keep it short. We'll see in the next.